Okay, chapter review for our Chapter 8 test, Algebra 1. It's in our geometry class. This is where we're doing it. In section 8.1, you guys had, comparing graphs. I gave you a document that had all the parent graphs already on it. Plot your pairs, draw your points, and then make a comparison like what's written here. So, number 1, the function was 7x squared. Because of the 7 here, this function is skinnier than the parent, skinnier than the parent. And reviewing our vocabulary, this is a vertical stretch when it's skinnier. Vertical stretch, add that to your document. 7x squared is skinnier than the parent was. When we look at the graph in number 2, I've got my parent on there, and I've got my 1/2 x squared. This 1/2 x squared is clearly wider than the parent. That's because of the 1/2. And we call that a vertical shrink when the parabola itself is shrinking towards, or shrinking away from the y-axis. A vertical shrink. Add that to your review notes. Use that vocabulary. When we look at number 3, there's 2 things going on in our graph of number 3. The negative makes it reflect over the x-axis. It's reflected over the x-axis. And then the 3/4 makes it wider than the parent, and wider is a vertical shrink. Wider than the parent. Number 4 is similar in that it's got the negative out front. That negative is making it reflect over the x-axis. And then the 6 is actually making it skinnier than the parent, or a vertical stretch. It's stretching towards the y-axis. Vertical stretch. Skinnier than the parent. So notice that when our function, whatever difference our function is from the parent, I'm just going to put so the parent is x squared. F of x equals x squared, or whatever we want to call it. Anything beyond the x squared needs to be discussed in your comparison. The negative makes it flip, the 6 makes it skinnier. Number 6, the parent function is sitting here, and all that happened is 5 was added to it. So this is actually the exact same shape as the parent, but we call this a vertical translation up 5. All that happened is that plus 5 moved that parent 5 units up the y-axis. Similar thing going on with number 7, but we do have this negative out front. The first thing that we have to consider is that this was reflected over the x-axis. Then we want to consider that this x squared parent function, after it was flipped over, was slid down 4. So we have a vertical translation down 4. Nothing changed in terms of wider or narrower, because the only thing stuck to our x squared parent is the negative. Vertical translation down 4. For anybody watching this, they might think, wow, she's going pretty fast. Ooh, I skipped over number 5 too. Wow, she's going pretty fast. What's the deal with this? This work should be presented and done. It's just checking in that you've got all your descriptions correct and that your graphs are looking okay. I did realize, though, that I skipped number 5. Let me go back over to this document. I'm guessing some of you did the same, skipping over 5. And then I'll go back and finish the others. In identifying the characteristics of a quadratic function and its graph, I went right to the front page of our notes packet where it says characteristics of a quadratic function. Talking about what's there makes me go and say, all right, I need to identify that the vertex is sitting at 1 and -3. Also in there was the idea that the axis of symmetry follows through the vertex and has the equation. Axis of symmetry equation. Axis of symmetry is going to be the equation x equals 1. Be sure that you're actually writing it as an x equals equation. That's the equation of a vertical line. And then the other thing that's discussed is what's going on related to the parabola as it's going towards the axis of symmetry. So what I'm going to say is that the quadratic is decreasing as it approaches that axis of symmetry, x equals 1. It's going down, and then as it moves away from the vertex and the axis of symmetry, it's increasing as it moves away from the axis of symmetry. Cool. So characteristics: vertex, axis of symmetry, and it's increasing, decreasing. Again, that was on the front page of our notes packet. So where am I at here? I had graphs done. I hadn't flipped my paper over. I rocked through number 6, moved up 5, reflected over x, moved down 4, and flipped my page over. So in number 8, this one looks a little bit more complicated. I want to break it down for you and think about it in steps. The first thing that would have happened to this is this parent function would have been flipped over the x-axis. First things first, we see a reflection over the x-axis. After the reflection over the x-axis, let's consider what the 2 did. So the parabola is down here reflected. The 2 made it narrower. The 2 made it narrower. I can see the narrowness here, skinnier than the parent. That's a vertical shrink. Oh, no, wait, skinnier the parent went towards the y-axis. Sorry, that's a vertical stretch towards it. And then the plus 6 gave you a vertical translation up 6. In this equation, we've got the negative, the 2, and the 6 to talk about. In number 9, we've got the third to talk about. What did the 1/3 do? The 1/3 made the parabola wider than the parent. It's moving away from the y-axis. We call that a vertical shrink. And then the -5 gave me a vertical translation down 3. Vertical translation down 3, down 5. Cool. Now, that wraps up everything on the first page. I'm going to flip over to go to the next page here. 10, 11, 12. You may not have put the 10, 11, 12 on these graphs with the parent. You didn't need to have the parent. You needed to have the graph, and then we're going to describe the domain and range. The vertex, I wrote down the vertex of each one. Here's my x squared minus 2x equals 7. There's not any reason to believe that our domain is all real numbers for x. There's no reason why we have to put restrictions on what x value we can plug in. But what we do know for the range is that the y values are never going to go below that minimum of 6. And since it's a minimum, I need to say that the y is going to be greater than or equal to that 6. Again, it's based on the minimum where that vertex is. Now, number 11, what I found that when I graphed number 11, I didn't see the vertex in the table of values. So I used the process of taking the opposite of b over 2 times a and simplifying that down to find out what is the x value of the vertex, and I had a half, 0.5. When I plugged 0.5 back into the equation, I found out that the maximum value that this vertex went to, so that vertex was at 0.5 and negative 3.25. That was significant because it defined what the range of this was. Domain on this one, all real numbers for x. Again, no reason to believe we can't use any x in this function. But what we know for the range is that since this is a maximum, y values all have to be less than or equal to negative 3 1/4. And again, if you don't see the vertex in your calculator's table, you need to you need to go and calculate using that x equals the opposite of b over 2a that we learned earlier on in the chapter to figure out the x value of the vertex. And remember, that's the axis of symmetry equation too. Number 12, last one for domain and range. The vertex of this one was sitting at 6 and negative 8. This is going to be a minimum since it's opening up. The domain, x is going to be all reals again. And then the range, y values have to be greater than or equal to this negative 8. When it's a minimum, it's the greater than or equal to. Now, last but not least, we find in number 13 that we've got a word problem. There's nothing about graphing. And actually, this is a good one because as we look in this, I've already gone to my calculator and realized I can't get much information out of it. We've got a pumpkin that's launched from a catapult. Sounds kind of fun. I think it's going to be going on in the science department here soon. When does the pumpkin reach its maximum height? What is the maximum height of the parabola? So this is all about what is the vertex. So what I'm going to do, and again, I already looked into my calculator and saw that I didn't get the vertex easily from a table. I'm going to grab those A, B, and C values. A is -16, B is 88, C is 12. And I'm going to go and use that to figure out, first of all, what is the X value of this vertex. Up top, I'm going to put my 88 in the bottom, 2 times -16. So as I just simplify this before I grab a calculator, -88 over -32. So the time there, and I don't even, oh, there we go. So the time of the maximum, -88 divided by -32, is 2.7 seconds in. I'm sorry, 2.75 seconds in. And now I need to go plug that back into this function to find out exactly what that height was. So -16 times that time squared, putting the whole entire function in, plus 88 times that time, 2.75 again, plus 12 at the end. -16, 2.75 squared, 88 times that. Oop, I better close up my parentheses before I add my 12. Looks like that's happening at 133 feet. When does the pumpkin reach the maximum height? 2.75 seconds. What is that height? 133 feet. Now again, the remainder of these problems, oh, we're not doing number 20. You can cross that one out, but the remainder of these problems, 14 through 28, are due when you come into class tomorrow. Test is Friday.